Let's start using AI to learn. Yay! We talked about in the last video that exploring and diving deeper into foundational concepts is the first use of using AI to learn. So I'm just going to jump into the script we've been working on in this video and demonstrate exactly how you can do that. And if we haven't met before, hey, my name is Erica Dietrich, or Erica the Dev Online, and this is our Learning to Code Using AI course for network engineers. So if this is the first video you're seeing, go back to the beginning of the playlist and watch the fundamentals. Muy importante.
Okay, I just want to be transparent that I am going to kind of show you through this in real time, like my thought process of how you can use AI to go through concepts that we have done before. But this isn't the most easy to like script or plan out video in advance. So I hope that this is useful to you, just kind of seeing me go through this process. So in our data structures video, we went over 3 data structures that I think are going to be highly useful to you as a network engineer, even starting out: a list, a dictionary, and a set. And we also wrote some example code in level 1 that we're going to continue to work with now to further learn how to work with these data structures and to learn some nuances about them. So let's pretend that we want to work with our list. I've got our code here in the middle. I've got our GitHub Copilot here on the right. I actually have the wrong project up on the left, so don't worry about that. So yeah, I have my list here, and you see it's called ACL list, and we were holding a list of ACL rules, right? If these were real rules, they would say something more meaningful than just ACL rule 1 or whatever, or be named something better, but this was just an example. So let's pretend we have this list of ACL rules, and now we want to be able to work with those rules. Like for instance, let's say that we want to be able to see what ACL rule 2 is for whatever reason, because maybe we're going to change it. Maybe we want to see if it's impacting some sort of network issue going on. And we're like, okay, I have this list, but now how do I actually work with the list? Let's go ahead over to our Copilot. I'm going to hit the plus sign for a new chat just to clear out that nonsense. You can see that we already have our context up as this file that we didn't actually ever name, the switch 1 days uptime equals 65.py file. I have 2 ways that I can ask questions about this list. I can use the chat to just generally ask questions about lists, as I showed you in a prior video, I think the previous video, or I can ask list questions in the context of what I've actually written here, which is always more useful. It's always more useful to provide additional context and for the information that the LLM gives you to be applicable to what you're actually doing. So it looks like it's not going to give me the option anymore to chat in line. I used to be able to do that. So I'm going to go down here. You can see I have ask mode chosen and ask Copilot, not edit or agent. So I'm going to ask the same question. How do I retrieve ACL rule 2 from ACL list? Okay. To retrieve ACL rule 2 from ACL list, use index notation with the element's position. So that's what that was index notation. So here's the thing though, it says 1, right? And you might think, oh, well, ACL rule 1 is index 1. But it mentions since lists use zero-based indexing, ACL rule 2 is at index 1. If you didn't know what zero-based indexing actually meant, you could ask additional questions to find out, right? I'm gonna tell you right now that in programming, indexes, there are other words for this, but I'm trying not to go into theory. Indexes start with 0. Anytime you have a list like this of something, it's going to start with position 0, then position 1, then position 2, etc. So ACL rule is actually index 0 index, or bracket 0 bracket, and then so forth. That's why ACL rule 2 is bracket 1 bracket. But we could ask, what is zero-based indexing and where does it apply? Is this only a Python thing? Now, keep in mind, I'm asking these questions to Haiku 4.5. I don't know why it's at the top of this list, because it kind of implies that it's like the best one, I feel like. But this is actually the lowest, one of the lower tier models. So if you weren't getting great answers, you could use a higher powered model. Copilot allows you to choose from multiple models here, right? We've got the GPT models from ChatGPT or OpenAI. We have the Gemini models, which are from Google, and the Claude models, which are from Anthropic. I actually don't know what this like Raptor and stuff is. I'd have to look into it. Okay, so zero-based indexing means the first element in a sequence starts at index 0, the second at index 1, and so on. It's not just Python. It's used in most modern programming languages. So yeah, that's been the case. Every programming language that I've ever used. I've done a lot of my work in C#.net. Same thing, also does zero-based indexing. So zero-based indexing applies to any ordered collection. So we've already talked about how lists are a collection or gathering of things where the order matters, right? So it does apply to list, and these are also additional structures where it matters. Arrays, strings, tuples, dictionaries, and sets. It says in sets when ordered, but sets are not ordered, at least in Python, so Again, this is where knowing your foundations means something, right? You have to have like a little bit of something to understand the answers it's giving you and to further prod and to question what it's giving you. Okay, so now you know. That is how you would retrieve the second item in that list. And if we want to actually see if that would work, we can do print underscore ACL list and then put the index in there. Now you can't always just directly put something in a print statement like this, but print is used for string values. So this is a list of string values, so we can print it. If this was, if these were numbers, then I don't believe it would print. You know what, I'll just, for giggles, I'll confirm that. I'll put number 5 in there. Let's print ACL list 1 first. ACL rule 2, okay, because we're printing a lot of stuff here still. I should have edited this. ACL rule 2, so that's where we're printing it, right? And if we wanted to be better about it, right, we could do the F string. We could do the F string, which we learned about with our conversation with Sergey. This is the ACL rule. And then that means that it's dynamic. Oops. So, what did I do here? How do you freaking exit out of the inline? I don't understand. Let's see. Explain using Copilot is what I just hit. On line 33, you're using an F string incorrectly. There's a space between F and the quote, which breaks the syntax. F strings need the F to be directly adjacent to the opening quote. See, this is the kind of bullshit that we deal with in programming. You know, before we had AI, we used to have to manually figure out what the hell was going on and have this problem that we have a space between the F and the quote. Ugh. Isn't it so nice that AI just tells you that it's that tiny mistake and you can just fix it? Okay, well, that's not the only problem. All right, so it says the parentheses was not closed. No. Explain again, Copilot, because I'm having mom brain. And yes, I know it says I have a React project going on, is because the F string syntax is broken. Correct. Print F, this is the ACL rule. Oh, oops. Oh yeah, so another dumb mistake. So I put my string over here, ended my string right here. I want to end my string at the end because this is the entire thing I want printed, not just this. So it was causing an error. So this is a dynamic value that changes, right? It's a variable and I'm indicating that with the curly braces, but it is a string value still. ACL list index 1 is ACL rule 2 up here, which is a string data type, which means it's allowed to be printed. So let's run it. And now it says this is the ACL rule 2. Okay, beautiful. So that worked. And let me just, this is a number list, and it's not going to be 4 because that's index 3. It's going to be index 4 for number 5 over here. Okay, boom, boom. We're going to press play, and this is a number 5. Okay, so I'm full of shit. You can print numbers too. So let's use that as a learning experience. Okay, what are the limitations of a print statement? Is there anything that can't be printed? Print statements can output almost anything, but there are a few limitations. What you can print: strings, numbers, and booleans. Okay, so there is more than just strings you can print. List, dictionary, sets, blah, 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 blah. Limitations are circular references. If an object references itself, very large data structure, functions and classes. Okay, so maybe I'm crazy. Maybe this is just a Python thing where I can print anything. Maybe things have changed. Maybe I'm imagining it happened, but okay. At least as far as what I've taught you in the course, basically you can print anything. Okay, so anyway, let's move on. Remove this inline chat, please. Close. So annoying. So now we know how to get an item in a list. What if we want to know how to add something to the list? Let's say, well, let's ask again. How can I add ACL rule 5 to the ACL list? Explain, but do not provide the code. You're probably gonna have to use that a lot, like don't provide the code, just guide me through, help me answer, because even though we're in ask mode, it's been my experience that it's standard to provide code for everything that it answers with. Okay, so to add ACL rule 5 to ACL list, you need to use a list method that modifies the list in place. Python lists have a built-in method specifically designed for adding a single element to the end of a list. You call this method on the list object using dot notation, passing the new element as an argument. This method adds the element to the end of the list and doesn't return a new list. It modifies the original list directly. So after calling it, ACL list will contain 6 items instead of 5. Okay, so there was a few different concepts in here, right? So first of all, let's go ahead and ask it what built-in method adds a single element to a list. The building method is append. It adds a single element to the end of a list. You call it like this. So let's go over that information, right? It's using a lot of vocabulary, but we've already learned a lot of this. We just didn't quite use this vocabulary. And one piece of it's new. Okay, so if we want to add something to ACL list, we would do ACL underscore list. And then this is dot notation. Dot notation is when you use a dot and then you can access the built-in functionality around whatever this is, right? So lists are a built-in data structure in Python and they come with their own properties and functions. So because ACL list is a list, when we put ACL list and then dot, it opens us up to all of these functions. You can see them all listed here. All these boxes, I think, mean function. Whereas I don't know, they're supposed to be like properties or variables sometimes too. But these are all of your functions, right? So you could play around with this on your own and not even use AI and see like, oh, what happens when I use extend or index or insert or pop? So append will add it to the end of the list. I'm assuming that insert will add it at a specific point in the list. And again, you might be wondering like, why don't you know this, Erica? And it's just, I code amongst different languages and I've also been off on maternity leave. And you also just like, developers forget these things too. We Google and ask AI all the time about little things, right? We know how to problem solve and break things down, but we don't just have everything memorized. So we're gonna do ahead and hit append. I'm gonna put in that ACL rule 5. I'm gonna hit tab to auto-complete it since it's auto-completing something I was already gonna write. And so here's the thing. If we print ACL list, what it was telling us above is this method adds the element to the end of the list and doesn't return a new list. It modifies the original list directly. When we print ACL list, it will now have that many items. So let's go ahead and just demonstrate. Let me add a print statement up here. Before we run this function, I'm gonna print ACL list. Oh, oops, I can't do it up there because I haven't actually defined ACL list yet. So let's print it right here, print ACL list. And just so that we can actually read the print statements, I'm gonna say, this is the original list. And then put it in my curly braces because it's a dynamic value, whereas this is just text. So this is the original list and we're gonna get the value for it. Let me take this out just so there's less clutter. And then I'm going to, after we do this action, I'm going to say, print, this is the list after appending. I just auto-completed what it was saying because I wanted that. Okay, perfect. So let's run this and see what happened. This is the original list, ACL rule 1, 2, 3, 4, and then number 5. This is the list after appending, ACL rule 1, 2, 3, 4, 5, and then ACL rule 5. You can see that the order of lines of code matters when you're doing something. You can see that the original list is modified, but that modification doesn't happen until later. What if for some reason we wanted to keep the original list intact for some reason and we wanted to create a new list when we append to it? We could try that too. So ACL list 2 is equal to ACL list dot, let's do the dot append ACL rule 6. Let's remove what we were doing before. And let's see if we can create a new list. So, and I'm gonna take this out too, because we've already proven that. All right, so after we've taken this action to create a second ACL list, I'm gonna say print ACL, oh, yeah. This is the original list, and then print, this is the new list. All right, let's see if it retained our original list doing it like this. Save, run, okay. This is the original list. So it still changed the original list. It still added ACL rule 6. And then it says this is the new list, none. So why is that? Why does line 37 print none? Because append returns none, not the modified list. On line 36, you're doing this. The append method modifies ACL list in place and returns none. So ACL list 2 gets assigned none, which is why 37 points. To fix it, okay, this is wrong. To fix it, this is the original list, this is the new list. That's the same, referring to the same list. Remove the assignment to ACL list 2, just call append on ACL list directly, then print ACL list. Okay, so yeah, that's not gonna work. So it just prints the original list, I guess. How can I create a new instance of the list that doesn't modify the original list? To create a new instance of a list without modifying the original, use the copy method or slice notation. So here, so you see what I'm saying? So I am trying to achieve a goal. I'm asking AI in order to figure it out. Then I'm trying it and I'm testing it. And I'm asking additional questions where needed to actually understand the concept. So append is going to update the original list, but if we want a copy of the list, we can do acllist.copy and then only modify that copy, or slice notation. So slice notation is a new concept to me too. So what is this? ACL list index colon append, both create a shallow copy of the list. Now ACL list stays unchanged and ACL copy is a separate list you can modify without affecting the original. Can you explain what slice notation is? Slice notation is a way to extract a portion of a list or a subset of a list by specifying a start index and index an optional step. Okay, so slice notation would be most useful for when you want a copy of just part of the list. Obviously, you could copy the entire list, which is basically what AI is saying, but it sounds like using the built-in copy method or function is best for copying the entire list, whereas if you just want part of it, use slice notation and say exactly where you want it. I think the insert method is going to be used to add a value into the middle of a list somewhere, but let's find out. How can I add ACL rule 1.5 after ACL rule 1 in ACL list? To add ACL rule 1.5, use the insert method, so I was right. How it works, use the index and then the element. So you are using the index to tell Copilot or whatever, your IDE, to tell Python. You're using the index to tell Python where in the list you want to insert, right? So insert at index 1 means you're going to insert where ACL rule 2 is. So 0, and then this will become the new 1. And then what you want inserted. So let's try it out. I'm just going to copy here for simplicity. Print ACL list. This is the list now. All right, this is the list now. Blah, blah, blah. Hey, there you go. You see ACL rule 1.5. After ACL rule 1, it's an index 1. It's also before ACL rule 2. Okay, and this is how learning with concepts you have learned already go, whether you are learning it for the first time or if you're like me and you're trying to remember what you're doing. So you can use AI for very practical learning of foundational concepts like, hey, how do I do this? How does this work? But you can also use it for theory. So I just gave you some examples in a prior video of differences between a list and a set, like an easy way to think about both. But there are more differences than what I stated in that video. So let's ask Copilot about it. What are the differences between a set and a list that I need to know about? Okay. Key differences. We mentioned this. Order is, a list is ordered or maintains its sequence and a set is unordered. The order doesn't matter. We've mentioned that in a prior video. But something we didn't mention is that duplicates are allowed in a list. You can have multiple of the same thing in a list. Duplicates are not allowed in a set. If you try to add a value to a set that already exists, you will not see it when you go to use that set again. And you can see the additional differences here. Some of it are terms that we have not talked about, more theory, right? Like mutable. Again, if you care to go further in your studies and you care to know what this means, because it will benefit you. Even the theory of computer science, it does help you as a network engineer. It's just, I think that it's less fun for y'all because a lot of y'all don't find coding fun. Like, you got into network engineering for a reason. And so you just want to learn what you need to know, right? But it's not like you're going to waste your time learning these things. They still apply to network automation, right? So what does mutable mean? Mutable means an object can be modified after it's created. So there you go. Sometimes you create things that cannot be modified, like the original cannot be modified, and sometimes you can. So in this case, you can. And it turns out that both lists and sets are both mutable, or the original can be modified. Here's some immutable types, or things that can't be changed after creation. Strings and numbers. Okay, that makes sense, right? We could go on and on with learning in this video, but I've shown you how you can learn more theory. I've shown you how you can practically ask more questions to learn how to use the concepts we talked about in our prior videos in level 1. And we also even used AI to ask questions about the code and to do a little bit of basic debugging. I hope this is helpful. If you have any questions or you want to see more examples of doing things, let me know down in the comments. Obviously, we used AI to learn and review things that are quote unquote more basic in programming and that we already have exposure to, but later on in this level, you can use AI to learn things that are brand new to you and that are more exciting. So thanks for being here, and I'll see you in the next video.